Hello everyone, let's continue the design of the spur gear. Here today we are going to discuss effective load on gear. Last time while studying the Lewis equation we have seen that this beam strength of the gear should be greater than effective load on the gear. So let's discuss what is the effective load. We know that the tangential component of gear is Pt is equal to 2mt divided by d dash, where mt is nothing but the torque. So here I am going to use this mt symbol for torque, which is equal to mt is equal to 60 into 10 raised to 6 kilowatt, that is the power, divided by 2 by n. So we know that this tangential component of the force which is dependent on the torque, and torque is dependent on the rated power and rated speed. Now what is rated power and rated speed? That it is the amount of power that designed under the normal conditions. But in practical application, torque developed by the source of power varies during the work cycle. Similarly, torque required by the driven machine also varies. The two-side balance is done by the flywheel. So here in gear design, the maximum force due to maximum torque is the criteria. This is accounted by service factor. So let's see what is service factor. In design process, the various calculated value of load, that is torque and stresses, are average value of the load. And this average value is from the range of the load that component has to bear in order to account this overload factor, or it is also called as service factor, which is used to design. The service factor is equal to maximum component of load to the average value of the load. So it is maximum torque divided by average torque. Let's take one example to understand the service factor. In electric motor, certain load is using pulley and belt arrangement. The value of the load at the start of the lift is much higher than the average load to be lifted. Thus, to avoid the failure of the machine component, such overloading service factor is needed. So here in condition of the gear, let's just write Cs is equal to, in terms of torque, it is mt max divided by mt. So which is correlated with Pt max, that is tangential force component, divided by Pt. So let's just rearrange. It is Pt max equal to Cs into Pt. Now one more important factor is there to study this effective load, that is nothing but the load concentration factor. Now we know that in Lewis beam strength equation, it was assumption that the tangential force on the gear is equally distributed over the face width. But practically, because of misalignment of the gear, bearing, or error elastic deformation of the gear, or supporting element like bearing, housing, or casing, the tangential tooth load get concentrate at any position, so that this tangential force will concentrate at any position due to misalignment or inaccuracy of the tooth profile. So to consider this effect, we need to study about this load concentration factor. So the load concentration factor range is given. Let's use the symbol Cl for load concentration factor, and it is within the range of 1.3 to 2.2. The lower value is used when the mounting is precise, which is recommended more precise, than we use the lower value of load concentration factor. But when average mounting is there, then we are going to take this higher value, that is 2.2. Now next is the velocity factor. So to study the velocity factor, we must know about that when gear rotate very slow speed, almost at zero velocity, the transmitted load Pt can be considered to be the actual force present between the two meshing teeth. Okay, but In most of the cases, the gear rotates at appreciable speed and become necessary to consider the dynamic force resulting from the impact between the meshing teeth. The dynamic force is induced due to inaccuracy of the tooth profile, error in tooth spacing, misalignment between the bearing, elasticity of the part, inertia of rotating disc. So there are two methods to deal with this dynamic load. Approximate estimation of velocity factor in primary stages is the one, and precise calculation by Buckingham's equation. So the primary stage, that is approximate estimation with velocity factor. It is difficult to calculate exact magnitude of this dynamic load in primary stages. So the velocity factor is developed by the birth is used. So the values of velocity factor is given below. Firstly, CV is equal to 3 upon 3 plus V. When the ordinary cutting is there, that is cutting made with form cutter, and the velocity is less than 10 meter per second, then we use this velocity factor, that is 3 upon 3 plus V. When the accurate cutting is there, which is using by the Hove cutter, and the velocity is within the range of 10 to 20 meter per second, then the formula of velocity factor by the birth is 6 upon 6 plus V. And when more precision gear manufacturing is there, after the cutting, the shaving and grinding process are done, then and also the velocity is greater than 20 meter per second, then we use this formula CV is equal to 5.6 upon 5.6 plus V, under root of V, where V is nothing but the pitch line velocity, and that is equal to pi dn divided by 60 into 10 raised to 3, where d is nothing but the pitch circle diameter in mm and V is nothing but the pitch line velocity. So effective load at the end, we can say that the effective load P effective is equal to CS service factor, CL load concentration factor into PT, that is the tangential force, divided by CV. So this is the value of effective load in primary stage of gear design. Now next lecture we are going to see the secondary stage of gear design, where the effective load is defined by the Buckingham's equation. Thank you for watching video.